Okay, this is a question on application of differentiation. Okay, firstly, a trapezium ABCD has a pair of parallel fixed sides of length a cm and 2a cm. So the other two sides of the trapezium are increasing at the constant rates of 2 cm per second. So this side is a cm and this side is 2a cm. The other side refers to this side and this side. Don't mistake it for the vertical height. Okay, this not the other two sides is not the vertical height because they are not the sides of the trapezium. The vertical height is not the sides of the trapezium. So given that angle ABM and angle DCN equals to theta, so theta stands for the same value, how fast is the area of the trapezium changing when theta equals to 60 degrees? To do this kind of question, we start from the question first. We don't care about this block of information first. This entire block of information, we don't care about it first. Alright, actually the entire block of information stretches from here to here. Okay, so we don't care about it first. What we care about is what they ask of us, which is this part. What is the question asking? It's important to identify that first. So let A be the area of the trapezium. We write down the question in mathematical format. So what does it means? So the area of the trapezium changing. How fast is the area? Fast. How fast means the rate of change of area. Because we are talking about time over here. And the area is the thing that is changing. So the thing that is changing will be on top. And the thing that is varying will be on or at the bottom. It's always the case. Let's say the rate of change of volume would be this. If I talk about rate of change of volume with respect to the surface area, then it would be this. With respect to what would be below, right? Because we are varying the area. In this case, we will be varying the area. Okay, so that's case. Now, dA over dt. When we always indicate with a vertical line, theta equals to 60 degrees. So therefore, the first thing we can think of is the chain rule. Okay, how to get from here to here. Then before that, okay, this is what we want to find out. And what is it that we have? Now we come to what is it that we have. What are the clues that we have? They say the other two sides of the trapezium are each increasing at a constant rate of 2 cm per second. Okay, we let this side be. What is this side? Okay, we could let it be y. Okay, and see then what is the rate of change of y. The rate of change of y according to this sentence would be constant rate of 2 cm per second. The two sides are changing at the constant rate of 2 cm per second. So dy dt equals to 2. Okay, actually I know that this is also y. How do I know it? Because this is also h. Okay, if theta is the same, if the theta and theta here is the same, and the h and the y is the same, so tangent theta, sine theta equals to h over y. If I know that this h is and his h is the same, then the y must be the same because they have to follow the same ratio. Okay, which means that this side will also be the same as this side. Okay, because tangent the cosine theta will equals to this side over this side. Right, since this and this side is the same, then this side and this side must be the same. Okay, because we can also think of it as the rule that the congruency, right, and similarity. Okay, we have a right angle triangle, and there's the same angle. That means this angle must also be the same. If this is a right angle triangle and this is right angle triangle, these two angles are the same. This means that this angle must also be the same as this angle because sum of angles might add up to 180 degrees for both triangles. So this angle must also be the same as this angle. Since they have all three angles the same, That means they are similar. We have established that they are similar triangles if all three angles are the same. Plus they have one side the same. That means they must be congruent triangles. Okay? So since these two triangles are congruent, so the three sides must be exactly equal. So since this side is equals to the length of this side, then what must be its length? So you compare this length with this length. These two lengths are parallel. So 2a minus a. So that means since two lengths must be are parallel, this length is a, this length must be a. So then these two lengths add up must be a as well, because when these two lengths add up, a plus a will give you 2a. Okay, so this side is, these two sides add up to a, so each single side is half a. Can you see that? Okay, so each single side is half a. Then we look at this. So cosine theta. So now let's say if we express everything in terms of h and a, then this length is, by the Pythagoras theorem, is square root h square plus half a square, isn't it? Square root the square of this plus the square of this, because this is the longer side. Okay, so but before that, okay, why do we need to find all this? Okay, the reason is this. Okay, we have dy dt. Okay, so what is dA dt? dA dt, we know what is area of trapezium. Area of trapezium is defined by half times height, which is h in this case, and the sum of parallel side a plus 2a. Okay, equals to half times, okay, it's easy, 3a plus 2a is 3a, so 3 over 2 ah is the area of the trapezium. So then if we have this, and we know that we want dA dt, intuition is like we have to find dA dh. dA dh, because h can be differentiated. A can be differentiated with respect to h. So we want to find dA dh. We want dA dh, how do we get to here? So dA is here, so dA must be on top, and then we want dt below. Therefore, and the medium, the connecting one is dh, so that this would cancel away with this, and then we'll get back to dA dt. So dH dt, okay, dA dh, can we find dA dh? dA dh we can find from here. So dA dh is just 3 over 2a. Okay, simple, because a is a constant, so we can just differentiate the h. Okay, then that means we have 3 over 2a times dH dt. What is dH dt? We don't know dH dt, but we know dy dt. Okay, so the intuition is dH. We want dH on top, and we want dt below. We have dy dt, so this, we let this be dy dt, and then this would be dy as well. Okay, so when these two cancel, you give me back to this one, right? So then what is, so this is 3 over 2a multiplied to dy dt, which we know is to be 2, multiplied to dH dy. So we are left to find, what we are left to find is just dH dy. So we must find a equation that connect h and y, isn't it? So let's see what we can do. What is the equation that connect h and y? So we know that y equals to square root h square plus half a square. Okay, so instead of finding dH dy, we find dy dh first. Let's say if we find dy dh, then later we'll invert it to get the dh dy. So then based on, so this, when we differentiate respect to h, this will be half h squared plus a squared over 4. Okay, this term is a squared over 4 times, then okay, power minus 1, so minus half, then chain rule. Most of students make mistake here, forgot the chain rule that we need to differentiate inside with respect to h one more time, so we have 2h. This is the correct answer. Okay, so then we will substitute this back into the earlier part. So let's see. We need more space, never mind. So we get 3 over 2, 2 and 2 would cancel. So we will have, and this 2 and 2 would cancel. So it simplifies the thing. So we have 3a multiplied to the h over here. And because the power is negative, so root negative half is just root at the bottom. And then we'll have h squared plus a squared over 4. So this seems like, okay, this is the, but okay, what is, then we want theta equals to 60 degrees. Now a is a constant, but h, is h changing? H isn't, h, is it changing or not changing? H is okay, did they say that whether trapezium has a pair of parallel sides of length, the other two sides of the trapezium are each increasing at the constant rate of 2 cm per second? That means my h would be affected when these two lengths change. It's like the h will increase as well. So h is also a variable, right? So then we must try to find what is h when theta equals to 60 degrees. Okay, so let's see. Well, h is when theta equals to 60 degrees. So tangent theta, we know that equals to h over half a. That is the opposite, h is the opposite side of the angle theta, and adjacent side is the half a. Okay, and because tangent theta, we know that tangent, okay, when 60 degrees, right? So multiply by half a will give me h. So what is tangent 60 degrees? We know that the triangle 60 degrees, this is root 3 and this is 1, right? This is 30 degrees and this is 90. This is the standard triangle. So tangent 60 degrees will be opposite over adjacent, so will be root 3. So end up my h is just equals to root 3 over 2a. Let's substitute root 3 over here. So then, right, so we will, let's see this thing. So we will simplify this, equals to root 3 over 2a. So we will be 3a times root 3 over 2 times a. That will give us then over square root. Root 3 over 2a, the whole thing square, the square of this will become 3 over 4a square plus a square over 4. Isn't it? So then this one will be a square also. Okay, so let's see what it simplifies to. Okay, so equals to, so 3/4 times 1/4 plus 1/4 would be 1. So inside would be a square. A square with square root would become a. A and a would cancel. Right, so they're left with 3 root 3a over 2. So the equation connecting y and h is, we realize is this. Okay, so we just like y equals to square root h square plus a square over 4. Okay, half a whole thing square is just a square over 4. So then I would find dy dh. What I need is dh dy, but I can find dy dh and then invert it. Okay, so let's say dy over dh equals to, when I do this, is just half bracket h square plus a square over 4 minus half. Alright, this is the chain rule, and chain rule. So I must remember to differentiate inside with respect to h again. A is just a constant, so a square is just a constant, so when I differentiate with respect to h, this becomes 0. But this h square, when differentiate with respect to h, will becomes 2h. Okay, so then to simplify, these 2 and these 2 would cancel. So this is just h and square root h square plus a square over 4. Okay, then when we invert it, it's just dh over dy equals to, the bottom goes to the top and top goes to the bottom. That's what we mean by, let's say we invert, because on the left hand side we invert it, so the right hand side we must invert it as well. And now we can put this substitute back into here. Okay, so this would be erased off, and we will write equals to, since these 2 and 2 would cancel away, so this would be just 3a, and I will multiply to root h square plus a square over 4 over h. Okay, I need some space here, so I erase away the earlier working, but you know how we get there. So then here, this one, for h is a variable, so we do not want to leave the answer with a variable inside. So what is it? When theta equals to 60 degrees, what is my h? That's what we need to find out. So since h, we know that h tangent theta, based on this triangle, tangent theta equals to opposite h over adjacent half a. Okay, and this is just 2h over a. Okay, so tangent, when theta equals to 60 degrees, because we want to find the rate of change of area when theta equals 60 degrees, so tangent 60 degrees equals to 2h over a. So h would be equals to tangent 60 degrees. Remember this triangle 3, 6, 9, so 30 degrees, 60 degrees, and 90 degrees. The sides would be 1, 2, and root 3. Okay, so tangent 60 degrees is just opposite over adjacent would be just root 3. So tangent 60 degrees is root 3. So this would be root 3 equals to 2h over a. Then that means h equals to root 3a over 2. Okay, now I substitute everything back inside the here. So I have 3a, then root 3, then what is h square? H square is just the square of this would be 3 over 4a square, then plus the a square over 4 here, a square over 4 over h. H is just root 3 over 2a. Okay, and this would be 3/4 a square plus 1/4 a square will just be a square. Okay, 1a square. 1a square root would be just a, so top would be 3a square. 3a square. 3a times a would be 3a square. Then here, this divided by this is so the 2 will go to the top, divided by, continue to divide by root 3a like this. So cancel top and bottom, right? So 3, this would becomes 2. 3 divided by root 3 is just root 3, and then we have 2 root 3a as the final answer. So that is the answer to this question. The rate of change of area is, then I'll add the unit square per second. Okay, because they gave us in cm, so this must be cm square per second, because it's area is in cm square. times second. Okay, so that would be the final answer. Thank you.